Okay, this is going to be the Chapter 6 review, so we're going to be talking about radicals, exponential, and graphing radicals and inverses. Okay, so just starting off with some square roots. Remember, we can write them big, we can also write them small. Square root of 64 is 8, and square root of 169 is 13. You could also type it in your calculator, just make sure both of them are underneath the square root. Okay, if you want to split this up, you can, so you're taking the fifth root of all of them. If you type in your calculator the fifth root of 32, you type in the 5, the second button, the caret button to get it to be the fifth root, 32, and press enter, you get 2. How many times can 5 go into 10? It can go into it twice. That is why it's 2. How many times can 5 go into 2? It can't. So the z squared is just going to be staying inside because nothing can be simplified and brought out. Okay, if I don't see an exponent, remember we add 1 because nothing else can be simplified in here. So let's do power to a power. Power to a power, we multiply. So I now have 16 to the negative 3/4. A to the negative 3 times negative 3/4 gets me negative 3 times negative 3/4. A 9/4. We have to drop negative exponents, so I have a to the 9/4 over 16 to the 3/4. This represents your exponent, that's your radical, so I got 9 square root a to the 4th over, I'm going to type in 16 to the 3/4 in my calculator, and it simplifies to 8. Okay, that squared and a plus sign here means I need to write it out twice. So I have negative 3 plus the square root of 2 times negative 3 plus the square root of 2. I have two binomials, so I'm going to FOIL. Negative 3 times negative 3 gets me a positive 9. Negative 3 times the square root of 2 gets me a negative 3 square root 2 because there's no radical to multiply into. Negative 3 times the square root of 2 gets me negative 3 square root of 2. Square root of 2 times the square root of 2 is positive square root of 4. We can combine these to get a 6 square root 2. Remember, adding and subtracting, we always keep the same radical. Square root of 4 is 2. 9 plus 2 gets me 11. Okay, we are writing this in radical form, so this represents your exponent, that's your radical. The 6 is not attached to the 3 over 2. It has an exponent of 1. So I can't change him. He'll just stay out here in front, and then I'm going to rewrite my x with the radical and exponent. If I'm just keeping it in this form, I don't need you to simplify anymore. Okay, so whenever I'm dividing, always first see if something cancels. So write it in a big square root and see if anything simplifies, because it looks like my x's will simplify, my y's will simplify. So remember, when I divide things with the same base, I subtract their exponents. So 4 minus 2 gets me 2 on top. 7 minus 3 gets me 4 on top. So now, if I'm trying to rationalize my denominator, all I need to get rid of is that square root of 5 on the bottom. Okay, we can write it big, we can also write it small. Okay, so there's always a 2 out here if you don't see one. So right now I have 1 5. For me to get rid of it, I need 2 5s. That's what that 2 tells me. If it was the 3, that means I need 3 5s. So if I need one more 5 to get me to my 2, I need to multiply by one more 5. I do the same thing on top as I do on bottom. So 6 times 5 gets me 30 on top. And then we still have x squared y to the 4th. 5 times 5 gets me 25. Square root of 25 gets me 5. And then we see if we can simplify anything on top. So my 30, is there anything that when I multiply it, it will simplify, or I can type in the square root of 30 and press enter on my calculator, see if it gives me my simplified radical. There is no perfect square that goes into it, so he's fine. Remember, there's a 2 out here. How many times can 2 go into 2? Well, it can go into it once. How many times can 2 go into 4? It can go into it twice. And then we still have the square root of 30 left in my radical. Okay, so technically you could type this whole thing in your calculator. It will most likely give you the correct answer in simplified radical. If we can't do it that way, what we need to do is break it down into a form where we can add and subtract where they're all square root 5s. Okay, so if I'm breaking down 45, I can think of 9 times 5 gets me that, and I know I can take the square root of 9. So you're trying to think of, when you're breaking it down in your factor tree, a number that I can square root. Okay, 605, I know 121, and 5 can go into it. The square root of 9 is 3. The square root of 121 is 11. And then I have the square root of 5, which has a 1 in front. So now I can add and subtract these because they all have the square root of 5. 3 plus 11 gets me 14, minus 1 gets me 13. And then the square root of 5 just attaches to it. Okay, if we're trying to rationalize the denominator, I need to multiply the top and bottom by its conjugate. Okay, so we're going to have to FOIL on top and bottom. So I have square root of 5 times the square root of 3, so square root of 15. Now I got to do my outside, so 3 times 2 gets me the square root of 6. My inside, a negative 10 times 5 gets me 50. And then my last, a negative 10 times 2 gets me 20. On my bottom, if I FOIL, I got my outside, so I got square root of 10. My inside, I got minus the square root of 10. My first here, sorry I did that in a different order, my bad. I got square root of 25, and then my last, I got minus a square root of 4. Okay, so let's see if we can simplify anything on the top. I can't take a perfect square out of 15 and 6. I can with 50. 25 times 2 gets me that. And I can take the square root of 25 to get 5. 20, I can do 4 and 5, and I can take the square root of 4 to get 2. On the bottom, these cancel because they're same but opposites, which is why we use the conjugate, because the center will cancel. Square root of 25 is 5, square root of 4 is 2. So now I got 16 square root 5 plus, or square root 15 plus square root 6 minus 5 square root 2 minus 2 square root 5 all over. 5 minus 2 is 3. And none of that simplifies any further, so it's just really, really ugly. Okay, you could type it in your calculator and see if that top simplifies anymore, but it doesn't. Okay, right now I cannot divide them because they don't have the same radical, so let's go ahead and change them to exponential, because when we divide things with the same base, we can work with the fractions. So remember, these have exponents of 1s, so when I rewrite it, it's always exponent over radical, so I got 1/3 on top, and I got 1/5 on bottom. When I divide things with the same base, that's a 5. I subtract their exponents, so 1/3 minus 1/5. In fraction, I get 2/15. If it's in radical form, let's put it back in radical form. So that's my exponent, that's my radical. So I got 15 square root x squared. Okay, to get rid of the 3/5, we have to do the power of its opposite, so we need to flip it. Remember, whenever we have the weird little fractions like that, I need absolute value bars to my left side. 8 to the 5/3. 8 to the 5/3 gets me 32. To get rid of my absolute value bars, I have a positive 32 and a negative 32. We split it. I have to add 2 for both of them. So I get x is equal to negative 30 and x is equal to 34. We need to plug it back in and check to see if either of them work. So I got 34 minus 2 to the 3/5 equals 8, and negative 30 minus 2 to the 3/5 equals 8. So you can type that in your calculator, just make sure you use the parentheses. So if I do 34 minus 2 to the 3/5, I get 8, so that one worked. If I do negative 30 minus 2 to the 3/5, I get a decimal, so he did not work. Okay, rewrite the equation and describe the translation. So we want to rewrite this so that if I were to graph it, it's not gigantic here. So I find a GCF. Normally it's going to be whatever's in front of x, which it is. So if I divide both by 16, I put it in front of my parentheses. 16 divided by 16 is 1. 48 divided by 16 is 3. And I still have this minus 2. The reason I wanted 16 is because now I can square root it. The square root of 16 is 4, so it pops out of my square root because I took the square root of it. Now to describe the translation, it stretched 4. It went the opposite direction of what you think, so left 3. This one's the normal direction, so down 2. Okay, find the inverse. Inverse means we flip-flop x and y, so I have x equals 2y minus 4, and I want to get it into y equals mx plus b, so let's go ahead and add 4. So I have 2y equals x plus 4. Divide every single thing by 2. So I got y equals x over 2 plus 4 divided by 2 is 2. If you want to keep it like this, you can. I don't really care. Okay? Just make sure you divide the entire thing by 2. Okay? Simplify. So this is one. If I got them into the same fraction, I can't multiply them because they don't have the same base. But because they have the same radical, I can multiply these. So I got 6 times 16, which gets me 96. So now if I type in the cube root of 96, ooh, it's going to get me a decimal. So we're going to have to break this down and see if anything works. So I want to find something that I can take the cube root of that I can break out of 96. So first I'm thinking 8, because I want to think of something small. Well, 8 times 12 gets me that. So if I do 8 times 12 in here, I can take the cube root of 8 and get 2, and still have 12 left. I can't break 12 down any further, because 1 cubed is 1. I keep taking a 1 out, that's not going to change anything. 2 cubed is 8. I already took an 8 out, and 8 can't be taken out of 12 and be pretty. So that's as far down as you can break that one. Okay, so if we wanted to rewrite it into radical form, that's my exponent, that's my radical. So I have the 4th root of 81 to the 1st. Go ahead and type in your calculator to see if it simplifies any more, because it simplifies to 3. Okay, we need to get the square root by itself, so we need to get the things not attached to it gone first. So we're going to subtract 8. So I have x plus 3 equals negative 4. Opposite of square rooting is squaring. I use parentheses because negative 4 times negative 4 is a positive 16. You are squaring it twice, so negative 4 times negative 4. These cancel, so it becomes x plus 3. Subtract 3 to get 13, and then we need to check our answer. So square root of 13 plus 3 plus 8 on the outside equals 4. 13 plus 3 gets me 16. Square root of 16 is 4. 4 plus 8 is 12. That did not work, so I have an extraneous solution. Okay, we need, it looks like everything's been moved near the radical, so we're going to go ahead and get rid of the radical by squaring. If I square my right side and have a plus sign here, it means I need to write it out twice. So it cancels on the left side, but I need to write out my right side twice. Do not distribute the squared in. The plus sign means I write it out twice. So I can FOIL the right side. X times x gets me x squared. Outside I get 8x. Inside I get 8x. And last I get 64. 8x plus 8x gets me 16x. If I factor that, I get back to square one, which I don't want because I don't want to do something I just did. So let's go ahead and bring everything over to one side by subtracting it to its common things. So I have x squared plus 13x plus 36 equals 0. Now I can factor what multiplies to get me this, adds to get me this, to get 9 and 4. And now I'm more on a route to get what x equals. Because I can do ZPP, if I set x plus 9 equal to 0 and solve it, I get x is equal to negative 9 because I subtract 9. If I set x plus 4 equal to 0 and solve it, I have to subtract 4, so I get negative 4. And now I need to plug it back in and check it. Remember, you're only plugging in 1 for both x's. So I have 3 times negative 9 plus 28 equals negative 9 plus 8. And the square root of 3 times negative 4 plus 28 equals negative 4 plus 8. So if you type this into your calculator, we get 1 equals negative 1, which doesn't work. If I type this one into my calculator, I get 4 equals 4. So the only one that worked in that situation was negative 4. Okay, if we're graphing this, remember my h always sits on the inside, so there isn't a number there, so my h right now is going to represent 0, and then negative 2 for my k value, so I'm not going left or right, but I'll be going down to negative 2. This means it is shifting down 2. Okay, remember inside is left and right, outside is up or down. Negative in front of my square root is a reflection over x. Negative inside my square root means a reflection over y. If it is a number bigger than 1 on the outside here, we're going to stretch it. If it's a number smaller than 1, we're going to shrink it. Okay, so if I type this into my graphing calculator, I type in y equals the square root of x, end your parentheses so that the minus 2 is on the outside of your square root. Okay, and it looks like I need more values on the right side. So I want to do 0, 1, 2, 3, 4. So I press second and graph to get my table. 0, I got -2, I got -1, -0.6. I'm going to scroll down. 3, I got -0.3 basically, and then 4, 0. So I got 0, -2, which I already got from my HK value, 1, -1, 2, -0.6, 3 is a little bit closer to that, and then 4, 0. So it should look something like that. So it's my original graph shifted down to. Okay. It looks like we can't move anything. We need to get rid of the square root, so I'm going to square both sides. The squaring cancels both square roots, so I have x plus 1 equals 2. I subtract 1, so I got x is equal to 1. We check our answer to see if it's extraneous. Oops, that's an equal sign. 1 plus 1 gets me 2, so it worked. So it's not an extraneous solution.